Hi everyone. I welcome you all to our live webinar today, which is organized by Meritroad Private Limited, an edutech company, which is supported by Amity. The topic for today's webinar is how data science is helping us in the current COVID crisis. Now, the term data science was first coined in the year 2001 by an American scientist called William S. Cleveland. It has been not even 2 decades, and this term or technology or concept has swept the entire world. And in today's scenario, this term has become even more important for two reasons. Primarily, millions of people across the globe want to use data science. They are considering data science as their future career. And secondly, the current administration and various government agencies are taking help of data science uh, in current COVID crisis management. So in today's webinar, we are going to discuss about three fundamental things. First, what is data science from a beginner's perspective? And secondly, uh, is data science really helping us in fighting COVID? And thirdly, if yes, how? If any one of these questions intrigue you, then this webinar is for you, and please stay on for next 60 minutes today. Uh, and to discuss this topic in further detail, I would like to call upon my distinguished guest speaker, Mr. Joy Bose. He is an inventor with 30 international patents. I will repeat it to my audience that he is a person who is associated with 30 international patents, and I couldn't have been more happier, having not having Mr. Joy on this panel, right? So, with this short, brief introduction, I would now request Mr. Joy to please address the audience and give a welcome note.
Thanks, Vikram, for that nice introduction. And thanks to all the audience for coming and joining us. So like this talk is more about, or this webinar interaction is more about like what data science is and how it can help in this current COVID crisis. So a little bit about my background. Like I've had about 15 years of experience after my PhD in different companies, including Samsung and Microsoft, and currently Imbibe. I have some experience in using data science in different environments for different use cases and so on. And also, like as far as my patents go, that they were mostly in Samsung and one was in Microsoft. They were more of related to web browser because I was working in those projects. It is of course relevant to which projects you actually work on. So it was about how to improve a user's experience when they are browsing on the web browser, basically. So for example, there are multiple kinds of patents. One was about EEG, which is about how you can use your thoughts to control a web browser. So that was one of them. Then there were many of them about how to get new kinds of interactions, how to interact with the web browser, with touch, with other kinds of interaction, new ways of using touch, new ways of applying pressure using your fingers, and so on. So anyway, the patent thing is, if you are in a research domain, then generally you will have some ideas and they will eventually develop into patents. So that's all I would say about that.
Right. Thank you, Mr. Joy. And Mr. Joy, before we really dive into all the deeper questions around data science and its application on COVID crisis management, do you want to briefly share what is data science to the beginners, and it is probably I don't know if it's a myth or it's a truth that it is believed that you need to have a strong technology background or a programming background and a strong mathematical background to be a good data scientist. So do you want to clear some air around it?
Sure. Thanks, Vikram. So basically, data science is, you can say it's a buzzword now, but generally, like it includes working with data and using the latest, mathematical models or machine learning models to work with data. There are also many related fields, including, machine learning, artificial intelligence, data wrangling, I don't know, data manufacturing, data creation, data visualization. So all of these comes in data science. It's basically that now we are in the era of big data, where there are like lots of small IoT, Internet of Things devices and other devices. Your mobile phone itself is producing so much data all the time. So it's about having techniques how to handle this kind of data to give better services to the users. For example, that if I have a web service, or if I am developing a website, if I'm handling a news website or something like that, then how do I kind of give the best experience to the users? If I'm launching a new product, then I've all got all the data about how many people are buying the first product, how many people are using the product. So by knowing all these things, we can kind of use data science techniques to analyze like how many people are falling off, like how we can increase the retention of people who are using my product or my service, web service or whatever. And then we can analyze these things. We can have hypothesis. It's kind of science. So you need to create hypothesis that why is this data behaving in a certain way, why is this number of clients going down, why is this number going up, and if I do this change, if I do a controlled A/B testing experiment, then this will become better, like more people will use my service. If I control this particular experiment, the less people use my service. So it's about that. So data science is using lots of tools, techniques, algorithms, mainly machine learning algorithms, but there's a lot of work even in the pre-processing part, which is how you kind of get the data, how you control it, how you kind of transform the data into a usable form, which people can use before the machine learning algorithms can be applied. So
Right.
it's like that.
Right. And what is your message to the beginners if somebody who doesn't have any programming background or any strong background in any mathematics? Do you still believe that person can still see data science as a prospective career option?
Of course, they're like basically for data science, it is working with data. So you kind of need to have a little bit of maths background. There are also things like statistics, probability, which you do need a little bit of background on, which most people probably are in the high school or the intermediate level itself, class 10, class 12. So maybe you will have to brush up those topics if you've forgotten or become rusty on them. But generally, maybe about a 3 to 6 months period would be enough for a beginner to kind of get some hands-on in this. For example, there are like websites like Kaggle, where you can handle lots of problems, toy problems, data science. Even Meritroad probably has got some courses that are available in data science. Someone can go and enroll in a course or seminar or a longer term course, maybe a 3 to 6 month course, where they can where they can be guided individually to do that, to learn the different topics involved in data science. Same for Coursera. There is Andrew Ng's course and many courses in this area, in data science and machine learning, algorithms, deep learning. So all of these areas anyway related. So you can start with any of them. Just dive in, and then soon you will pick up the skills that you need.
Right.
That's my advice,
Right.
basically.
So just summarizing basically to the audience that, as Mr. Joy Bose mentioned, that a beginner can probably, give 3 to 6 months of time to learn any online course, whether it's available on Meritroad website or go to Coursera or any other online platform where they help you understand the basics of data science, and they'll help you understand various techniques of machine learning. And of course you need to brush up all the statistical and maths concepts of probability that you learned in your school days, like in class 10th or 12th. And with those basic things you can obviously get started, perhaps as a data scientist. Right. Now with that, now let's dive into the second question, and which is the mood question for today's webinar. Mr. Joy, now can you please provide a high level overview um, of different ways in which uh, data science is helping us or can help us in current coronavirus crisis?
Sure. So the thing is like, if you look at this kind of pandemics, like this current COVID pandemics, every few decades, the humanity is hit with pandemic like that. Like we have had in recent memory itself, there's a SARS which happened in China. There was Ebola, which was in Africa mainly. Then if you look further down, further like centuries back in 1920s, almost like 100 years ago, there was a very big flu, kind of flu that kind of came, and millions of people died in the world. It was also a kind of virus only. Then there was the plague and so on. But the difference that we have now with this coronavirus is that we have got the tools and the techniques and the computing power to use the power of data to control the crisis. So we can use we not only need medical doctors, we need beds, hospital beds, all kinds of medical resources, but we also have the data resources available to us that we did not have before, especially in a case like in a pandemic like COVID, which is so infectious. Like there's a ratio R, and like maybe some people are super spreaders, they can infect 10 people at a time and so on. So in this kind of situation, it's very important to use data science to track who is getting infected, to kind of build models as to how fast the disease is spreading in a geographical location, or in a country, or in the whole world and so on. And also to even the treatment of the of the disease, to develop a vaccine, or to develop medicines for coronavirus, to do control testing even for that. So you need data science everywhere. Wherever data is involved, you need data science. To do any kind of hypothesis, any kind of control medical testing, you need data science. To sequence the COVID genome, you need data science. So in lots of areas, there's a lot of potential that data science.
Yeah, Mr. Joy, can you hear me? Okay, I think there was some. Uh, One second.
Yeah, I can. I'm unmuted now. It's okay. Thanks.
Okay. So, what kind of projects are actually running in different colleges and universities and around, fighting this coronavirus crisis?
So when you go to projects area, there are of course many different kinds of projects that are running. Um, there are of course, if you look at the India government level, many projects running in the IITs and IISc to kind of like small projects and large scale projects also, to kind of see the COVID data, to build the models to predict how fast it'll go, and even the government can can act on these, and decide, for example, when to start the lockdown and not. If you look at more international level, IEEE, which is the Institute of Electrical and Electronics Engineers, that have got their own funding for small projects. So people can apply for projects related to COVID, and if they can submit project proposals, and if IEEE likes it, they might even agree to fund it and so on. There is also like lots of projects by US government agencies. There are projects by the World Bank. The World Bank projects are more related to how the COVID crisis affects the economy of a country. Like how for example, if the lockdown is started, then how will the economic output of GDP and all these other things be affected? If it's lifted, then how long will it take for the economy to recover? This kind of projects. So there are multiple projects in multiple areas, and some of them maybe people can apply for funding. And also, if you go to, for example, the Kaggle website and search for COVID, you will find at least like 20-30 projects just like that, small projects which you can do in your own time, and just to get some idea of how to apply data science in that.
Okay. And um, okay. And basically, how are we using data science in contact tracing? Like we heard a lot, many times from many different sources, but using data science in contact tracing. A, how are we using that? And B, didn't we get enough success in applying data science in contact tracing? Because the
Yes.
numbers are really scary, right? If you look at the numbers in the world, they're really
Hello.
scary. Hello.
Hello.
Yeah.
Can you hear me?
Yeah, Joy, Mr. Joy, I can hear you. Can you hear me?
Okay.
Yeah, Mr. Joy, can you hear me now?
Uh, yes.
Okay,
Yes, I can
I'm
hear you.
saying, okay,
Yes.
I'll repeat the question. I'm saying that how are we using data science in contact tracing in the current pandemic? Because uh, because the numbers are growing day and day, every day. So are we saying that the data science didn't help us enough in fighting COVID crisis as far as contact tracing was concerned?
So there are, of course, a lot of contact tracing apps by governments and different agencies. For example, obviously in India, everyone has probably heard of Arogya Setu, which is an India-specific contact tracing app, and it's almost essential. If you go to the airport, you will have to install this app, and they will collect data about whom you have come in contact with, and so on. So in some other countries, they probably started with manual contact tracing app, where they have like paid full-time people whose job is to do the contact tracing. Means that if there is somebody infected with the COVID, then you kind of trace whom they had contacted in the last 24 hours or 2 days or something like that. But then also these apps basically automate this thing. The person can from the GPS location, you can find out which other people came in close proximity with these people, and then what is the probability that from this one infected person it will grow to many people, and so on. So in Singapore, there was a contact tracing app called SQREEN, Screen, which kind of used a kind of data science model to model and predict um, how many people might have come, even while maintaining the privacy of people. Like, you don't need to know who exactly has come, but the remember, what is the aim of the contact tracing is to control the spread by kind of knowing who might also be infected or who might be in danger of infection because they came in contact with somebody else who was already a COVID person. So by knowing this, maybe authority can put a lockdown so that nobody else apart from these people can come in contact with each other. So that will control the COVID. If you don't do that, then of course that person who is infected can reach out or touch or come in contact with many people, and it'll spread much faster. So this SQREEN app of Singapore government that, for example, uses data science to kind of model for each area. They break down the whole area into five meter square blocks and something, and then they model for a given area at a given time what is the density or what is the speed of the people coming in and out of that area, and based on that they kind of have a model to estimate how fast it might be growing, or which areas are more susceptible to the infection, which areas are less susceptible. So by
Right.
knowing this, maybe the government can make
Right,
decisions.
right. But it is always a debate, like the data that is shared
Yes.
for contact tracing. In a way, it is infringing upon the right to privacy. What is your thoughts on that? Mr. Joy, can you hear me? I'll,
Yes, I can hear you. Can you
yeah,
hear me?
yeah.
Okay.
I'll repeat the question. I'm saying that it is always a debate that the data that is being shared for contact tracing is also violating probably with our rights of privacy. What is your opinion around it?
I mean, this is a genuine concern. So there is a balance here, right? Like the balance is that people should not get stigmatized by their neighbors or something by thinking that there's this guy who's got COVID and let's not touch him or anything like that. On the other hand, people also have to be kept safe. So it is not just individuals thing, but it is that the government or whichever authorities there have to also control the spread of the COVID by making sure that the people who are infected don't come much in contact with others, especially in densely populated areas like India. So maybe one solution can be to anonymize the data. Means that you don't give the names or anything, but you kind of make sure that it is used in meta level. You kind of anonymize it using different techniques like differential privacy and other algorithms like algorithms to make sure that individual people are not identified, but the risk factor is identified. If you are going to an area, you know that there are 5 people who are in danger with this, but you can't identify those 5 people individually. But then at least you can know that maybe I should not go to this area, or that this is a more risky area and this is less risky area, and so on.
True. That reminds me to one of my previous webinars where I had a panel who was engaged with Israel government in fighting COVID crisis. they said that they were assigning a unique device ID to every person whose contact tracing, data was being shared with the server. So that way, that anonymity was being maintained, because user wouldn't know basically who is the person. They
True.
might know that
True.
there's a device around them which might be infected. The owner of the device might be infected, but that was one way of anonymity. I'm not sure if Arogya Setu is probably internally using the same mechanism.
Okay.
Any do you have any inputs there? Any observations there? How are we doing the same thing in Arogya Setu app?
I guess so. I mean, the government is trying their best. I'm pretty sure that to at least make sure that individual people are not identifiable. But of course, it is still necessary. Maybe they can improve the app also. I would of course suggest that if they can make sure that privacy is maintained. I don't know source code of the app because it's not open source, and some people have raised concerns about it. But I'm pretty sure these concerns will eventually be handled somehow to make sure the privacy is also maintained.
Right. Okay. Next, now let's move on to the next question. How did we use data science to essentially track the spread of COVID? Basically, how, or in the words, uh, did it really help us to decide which areas to lock down and which areas to unlock?
Um, so there are some mathematical models in the area of epidemiology, which is study of epidemics and how epidemics kind of grow. So this is not a new field. It has gone on for a while. But the new thing, of course, is that this epidemiology now has the advantage of data science to help it, make the predictions much faster and to get all the data. So there are models called like SIR and SEIR, which kind of you can Google it or Wikipedia them if any of the listeners are interested. So they are basically epidemic modeling algorithm, which kind of what they do is they have got differential equations, and these are the variables, like how many people are in more susceptible. I means how many people are infected. R means how many people have recovered. So you kind of model all of these this number of people using differential equations. And if you've got lockdown or something, then you can have a variable for that also, the lockdown variable in the same differential equations, and then you kind of solve them to kind of get the growth of the COVID, that how many infections will grow, how many recoveries will grow. So you kind of build these projections. So I guess if you go to some of the graphs that are coming, these models are basically used to generate the data for these graphs basically. So I mean, of course, different countries, including US and all, they have their own websites. There's a website called COVID-19 projections.com. They basically use similar kind of apps similar kind of models to based on the given data. It's basically you have your neural network model. You've got the data. You've got a differential equation with all these variables there. So you kind of fit it to the data that is available. So once you fit it, you can get the actual the real values of the variables in the model, and then you can get the actual thing at this time t. What will be if this time t this many people are infected, in time t plus 1, what will be the number of people infected? The data of a particular area, say Mumbai or Maharashtra or India, using these models, and then you can use it to get projections of how it will grow. And then of course the government can decide that if this is going to grow very very fast, then we need to have a lockdown in this area more. Maybe if this area suddenly COVID is growing a lot, then you can use it to lock down this area more. Of course there are other ways as well, using Twitter, or using like basically data science can be used to track an epidemic in the early stages. Of course, now COVID is not in the early stage anymore. We have already got like almost 3 lakh people in India who are infected. So in early stages, there are also other models which can kind of you can just analyze the tweets to quickly get the geography of it. Like a new pandemic starting here. So maybe if in Wuhan, when the COVID was starting in China in December or whatever, if they had used such models, they could have immediately tracked it. And if they had tracked it much earlier, then they could have simply closed the borders very very fast, and it would not have become a pandemic in the first place, I guess.
That is right. That is right. And that is definitely a common belief across different countries also. That had they, if China had probably handled this more proactively, that it would have made such a spread. But again, um, that is just a belief, right? So far, at least. All right. So let's now move on to the next question. How can we use data science for individual treatment? Basically, can we really find out, uh, if a person is really vulnerable to this virus, and if yes, then how long will it take uh, to get completely cured?
Of course. So basically, like every person is unique, of course, but you can kind of get data from a person. Suppose I'm a hospital, say, and I kind of need to decide whether to, a patient comes to me who has got some symptoms of COVID. Then I need to find out, or I'm a COVID testing app. So I kind of need to know how much is he or she in risk of contacting the disease, or even if he has contacted the disease, should he be hospitalized or not, or is it enough to do home quarantine or not? So we got all these features, the age of the person, the gender of the person, where he is coming from, what is the lifestyle, what is his social network, how many friends he has got, how many people he talks to, what is his profession. So getting all of these features together, and since we have the historical data of COVID patients, there are so many data sets available all over the world. You've got the US data set, Italian data set, Chinese data set. So by seeing which kind of people, or what kind of profile of people are more vulnerable, maybe that older people are more vulnerable, men are more vulnerable. So this kind of factors, we can kind of make a much more informed decision, which will be more efficient, whether to admit this person in hospital or not, or whether this person is more likely to get COVID or not, or maybe that they are it's okay for them to just self isolate in their own house or something like that. So this can help in freeing up resources, because the hospital beds are limited here, and COVID is not a cheap treatment. It's costs a lot of lakhs and all. So of course, by using this kind of machine learning related results, we can train a model and use it to predict how much is the risk factor of people. And of course, it can also be a population, that maybe the people from Arunachal Pradesh are more in danger, or something like that, less in danger, like that. So we can kind of make governments or hospitals or providers can make use of this data to optimize the treatment according to who is more at risk. So that is one aspect of it. Another aspect is about developing vaccines and medicines for COVID. So here also data science can be used, and it is being used. In, for example, there is a COVID gene, which is a DNA sequence of COVID. So they're all the protein sequence of AAT, GAT, G, like that. So people who are in the medical field would know better than I do. But basically, you can use natural language processing algorithms to kind of if a new gene comes. Remember that COVID mutates very fast. This virus mutates. It changes to a different variant of the same virus. So if you've got a new virus strain, how do you know it's a part of COVID, or it's just another flu, harmless flu or something? So you can use some kind of data science algorithm, machine learning algorithm, like decision tree or something like that, to know how similar it is to COVID variant. And also you can similarly get the tree of it, like the original COVID strain DNA was of this thing when it came from a bat, and then when it came to humans, the India COVID strain is different from the China strain, different from the Italy strain. So you can kind of see from where it came, like how it came from the original strain to the strain we have in India right now. So you can even track how it must have spread to India, this kind of thing. And this can be also used in making vaccines, because then you can kind of, once you've identified and isolated the strains, then you can tailor the vaccines to combat particular elements of it. Like this will COVID is this is how it attacks the cells. So if I use this vaccine, this will stop it from attacking the cells, or things like that. So in every aspect of it, you need data science. Even to, if you say you have developed a vaccine or a medicine, then to do human trials, you need to devise the A/B testing experiment, where you've got like two populations, one who's getting the medicine, one is not getting the medicine. So you have to kind of do a controlled experiment in properly scientific and making sure all the parameters are correct, all the parameters are controlled. It's not some other factor that is causing it or healing them, something like that. So even for controlled experiments, you also need data science knowledge and machine learning knowledge.
Right. So since you mentioned about data sets available from different sources like social media, maybe somebody's travel history, somebody's what do you say, family history, or his friend network. So As of today, what kind of COVID specific data sets are available?
Okay, there are actually a lot of data sets available. Like if you just Google, something like COVID data sets, you'll find so many links. But specifically, like the ones which are very accessible, and you can also work on them, analyze them using Python or R and so on. Like if you go to Kaggle.com, so Kaggle has got lots of data sets which are COVID related. Same goes for there are public data sets from Google. If you search for Google COVID dataset, you will find them. Then there are multiple data sets from different countries. So if you search for China cases dataset or Italy cases dataset, you will find that like I said, the UN, the WHO, the World Health Organization, they have got their own data sets. So there are actually quite a lot of data sets available, but I would suggest start with Kaggle, or start with one of these data platforms, data science platforms, and they themselves will have some data sets, and they will have some code also, and some simple toy problems where you can just go and start playing with them. Write a small Python script to kind of analyze how the COVID is increasing, or to predict which kind of people are more vulnerable or not, using the different factors and so on.
Okay. And how is this data and knowledge being uh, shared by different countries in terms of fighting COVID? Like, is there a mutual agreement between all the countries of the world where everybody's sharing data with everyone else?
Yes, I guess so. I mean, the thing is that COVID is a pandemic, so it affects all the people in the world. It doesn't affect just one country. It may have started with one country, but now we are all in trouble, I guess. So the only way we can fight it is together by sharing data. And thankfully, all we have got this organization, World Health Organization, and most of the data sets from different countries they already shared with WHO. And generally, if you search for data sets of any specific country, like data sets in Italy, then you can get it. So say I'm the Indian government, and I have got access to the Italy dataset. Then how can I use it? I can basically find out if these are the different factors that can help that make a person more vulnerable to COVID. Then I can make sure that in my country also people of that profile are better protected. If I know that cold places like cold countries are more in danger and hot countries are less in danger, for example, which is probably the case. The death rates are more in colder countries. Then maybe I can also make sure that my states which are in colder climate, that is help more and so on. If I know that older people are more vulnerable because in Italy older people are dying much faster than younger people, then maybe in here also in India also we can make sure that older people are warned in advance not to move around too much, to stay at home and do contact tracing, and we can offer them food and everything. We can make sure that their needs are taken care of without them having to go out of the house much and so on. So we can actually use this cooperation between countries, the data sets of every country, the techniques of each country, learnings from different countries, to find out like what is the best strategy to control it in our country. Like of
Right.
course in India we don't have a big medical system, like we are not a developed country, so maybe we can use some of their developed countries learnings to kind of optimize our resources as well.
True, true. And the data sets of other countries such as Italy or UK or US, is it publicly available on the web or only the government agencies can request for that data and use it for building their models?
No, these data sets are more or less very publicly available. I believe that Kaggle itself will have few of these data sets. Then WHO websites will have a few. Just Google them. Just go Google for Kaggle COVID dataset Italy, something like that. There's a website called lionbridge.ai, which has got a collection of coronavirus datasets from every single country. Like at least the countries that have made it public. So there is already a lot of datasets from different countries in Europe, in US, in Asia available, which people can actually use.
Right, right,
So anybody can use it. The data is completely free to use.
right. And how are we using data science in the development of vaccines or medicines?
Correct.
The-
So yeah. So like I said, right. The ways in which we can use data science is, of course, like we can use it to, like I said, COVID gene mutates. So you can find out if a new gene is there, unknown gene, then is it a COVID gene or is not a COVID gene? Similarly, if a person has already been admitted in hospital and he has got antibodies, he or she has got antibodies in their bloodstream, then how do we know if it's going to be effective or not? and use this kind of antibodies which extract the same serum of whoever was in the body for new vaccine or new medicine. So data science is used everywhere here. First to control testing of the medicines, then to do the DNA analysis of the antibodies and so on, DNA analysis of the COVID gene and the new mutating genes as well, and so on, to kind of know whether we are in the right track or not, or whether this medicine is not working with certain kinds of people and it's working with other kinds of people. So everywhere you see, in all these different ways, this data science is actually invaluable. You will say need it as a doctor, as a hospital, as a medical body. You need the help of the data and the techniques of data science to develop the vaccines, to develop the medicines for it. Like HCQ, hydrochloroquine. Is it good? Is it bad? I've heard reports from both sides. How do you know it? So you kind of have a control testing. You divide your patients into, one is like a control group and one is the treatment group, and then you kind of give HCQ, hydrochloroquine, to the treatment group, and don't give it to the other group, and then you see if they are recovering or not recovering. So then you can get a good idea. You can
Right,
use the statistical models to get that, I guess.
right, right. And given that, after this current pandemic, we've got a huge amount of data set. We'll perhaps probably come up with new models, which we could not do it earlier during SARS or Ebola. Do you think our current experience is going to be very helpful in fighting any future pandemic? And if yes, how?
Of course, yes. The thing is, we are getting better at it. I mean, data science as a field is also developing, and especially because of this COVID crisis, like all the countries have kind of woken up. They know that the only way we can fight this kind of pandemics is if we kind of pool our knowledge, if we kind of pool the data sources, and we pool our techniques to kind of know this. So for a new epidemic, if it comes, for example, some place in Africa suddenly got a new kind of fever with no doctor there knows it, and suddenly it's spreading a lot. Then right now we can kind of see, we can build a model to see the news reports that are coming, use NLP techniques to kind of know if how fast it's growing, whether it started from some place in wherever, Nigeria somewhere, and then it grew the whole of East Africa or something like this. Then we can kind of model it. We can, or it maybe grew in Asia. It started from Chennai or somewhere, and suddenly it's now got all of South India and so on. So we can quickly keep track of the tweets, of the news reports, all of these coming, and then we can kind of build the model to predict how fast it might grow if it's not controlled quickly, and whether this has a danger of becoming pandemic or not. Like maybe it started with only one person at a time. Even COVID, of course, started with only one person. Probably started with one bat initially, and now look, there are like lakhs and lakhs of people who got it. So if we had known this earlier, like I said, we discussed before, right? Like if the China government had immediately controlled it right in one city itself, then this would not be a worldwide problem today. Of course, this could have happened to any country. It's not like one government is at fault or whatever. So from this we can learn. This is not the last pandemic. This kind of epidemics, pandemics keep coming every few years. I mean, we can develop a vaccine for COVID, then it will mutate and it will come in some other form that we don't even know. Even SARS was a previous variant of COVID. It's not that different actually, as far as DNA sequencing goes. So definitely there will be new pandemics of this kind. And right now we have to learn the lesson that we have to control very fast. Every country should develop a task force, and task force should include data scientists whose job is to kind of see the data, the hospital data that is coming, the news data that is coming, the tweets that are coming, all of this kind of data sources, to kind of predict if a new disease has come and how fast it is growing, whether it's got a chance of becoming a pandemic or not. And then immediately the government should also listen to this and control it very fast. They have to also act. It's not enough that just data scientists make their models and predictions and the government doesn't act. So you need both sides. The government also needs to be much more, they need to listen to the experts and they need to act as well.
Right. I mean, that's an interesting perspective that, even the government bodies or, special task force need to have technologists, uh, such as data scientists in the team, so that they can actually come up with their suggestions or perhaps some kind of a solution. Because, somebody who is non-technical, he's going to take a lot of time to even understand the problems, forget about the finding the solution of the problem, right? So it is a great insight, Mr. Joy, that yes, it is indeed the time where different countries of the world should form a special task force where they should have technologists and perhaps data scientists in the team. And on a similar note, I heard that one of the state government, probably in India, has recently hired a CTO in the state administration. And again, this is probably one of the first step that has been taken by our government, perhaps in the right direction. But again, that is something that I'm not really sure of. I just overheard from one of my colleagues. All right. So moving on. Uh, Suppose we want to do a small project. Where can we find the data, and how can we really, how can we also help in fighting this crisis?
Like if if you want to like get into this, like become a part of like to just to see how data science can be used in practice, I would suggest just go to the Kaggle website. That's the easiest possible way, kaggle.com, and just see the COVID related projects that are going on. Generally each of these projects will have their own data set. Like they will already have cleaned the data for you, and they would have put the data there. So all you have to do is basically, if you go to the Kaggle website for a specific project, you will see other people and their code who have already tried to solve that problem. So maybe you can also write a simple machine learning model to predict whatever it is. It depends on the problem statement, of course, but maybe you can start with something simple. It's like logistic regression or something, and then you can go into more and more complex models, and then see whether your prediction accuracy is increasing or not, or whether you are doing as good as the other models that are already there. So if already people have put the solutions, their code, the Python code, or the notebooks will be there already in Kaggle. So you can kind of you can write your own code, and then you can compete with them, that this guy got 87% accuracy in prediction, and my code is getting only 78%. So how can I improve my accuracy? So this way you can become a better data scientist, and you can also work with real COVID data. So you can, there's a very good opportunity for people to actually use develop their data science knowledge and use their knowledge to understand how COVID can be fought.
Right, right. And what would be your message, Mr. Joy, to somebody who wants to build his or her career in data science? What should be the first baby steps, basically?
Okay, so I mean, baby steps. It kind of, look. Nobody comes from the vacuum, so everybody will have got some kind of background in maybe maths or in computer science and so on. I mean, data science is not the same as computer science. You don't need to necessarily a good coder, because in Python, what needs like 100 lines in C can be written one line in Python. There are so many machine learning libraries, so you don't need to write the machine learning code from scratch at all. It's just like one line, fit, predict. So it's much easier if you use Python and all. So I would suggest to them to do some toy projects, to maybe do some courses in places like Meritroad or other online learning websites, and then do some simple toy projects. Go to Kaggle, do a toy project, see how your data is coming. Then with practice and theory together, you have to balance both of these things. So you learn about all these techniques, buy some O'Reilly books on machine learning or data science, buy some textbooks, as well as maybe do some of the theoretical courses, as well as do the hands-on coding for some real data sets. So maybe do a 3-month course in one of these Meritroad or some other website, as well as keep on coding yourself until you get the confidence and the sort of mastery to get into data science full time. So don't just suddenly make a jump in your career, but make it a 6-month plan if you are thinking of going into this area. So make a long-term plan, and slowly start to take some time out every week, spend some hours in these websites doing these courses, invest a little bit of money in these courses. If it's a classroom course, even better. If it's not a classroom, online course, still okay. If it's not online, then you can even self-motivate yourself, do take some data set in Kaggle and work with it, and then kind of build your expertise from time to time. Maybe form a group with your friends and do that. So there are multiple ways, but you have to invest time, money, energy. There's no other way around it. You need to have the motivation to kind of drive yourself, especially if you're working in some other job.
Great, great.
Have to do that.
That is great. Those were all the questions I had, Mr. Joy, for today. Uh, do you want to give any concluding note to the audience for today?
Sure. I mean, as far as COVID goes, or the use of data science to combat COVID, one kind of warning which I would probably not like to miss is that look, this is the data science part is only one half of of the war. The data war is only one half of it. The other half is to do with the medicines part, like there has to be enough beds, enough hospitals, and whether the government will listen to what the data science will do. So it's not a magic trick where you just the data scientists just give the models and immediately the COVID is controlled. It's not like that. They can predict how many people will go higher or lower, but it is up to the government to act on these predictions. Also, like make sure that the resources, medical resources, are available as well. Also, there are other factors involved, such as the models can sometimes may not work perfectly, so you cannot always trust them. There's always a little bit of risk involved there as well. Maybe the data is not always reliable. Also, that even if everything works, there are things like people's behavior. You cannot control it. Like you can say that social distancing is good, but then in India, you see in Kolkata or somewhere, like lots of people are getting on the bus at the same time, right? So that's defeats the purpose of social distancing. So there are all these factors that are also there, which kind of need to be there in order to control COVID more seriously. So you need a cooperation between the government, between the public, and the data scientists in order to fight a disease like COVID, which is a pandemic. And all same goes for future diseases, future pandemics, and so on, I guess. So I
Right.
wanted to not miss out this one point.
Sure, sure. So thank you, Mr. Joy, for your valuable time and sharing such tsunami of knowledge with all of us. It was very insightful and very helpful to us. And yeah, uh, I will. The only thing I'll say is, with such a busy schedule of yours, it was indeed great to have you on our webinar today. Thank you very much.
So, thanks a lot, Vikram. It is very good to be there.
Yeah.
Thank
All
you.
right. Thank you. So back to the audience, I would like to conclude today's webinar by again answering those three fundamental questions which I asked in the beginning of the webinar. A, what basically is data science from a beginner's perspective? Now, as mentioned by Mr. Joy, it is not programming in isolation, nor it is maths in isolation. It's going to be a combination of both of them, right? And it is essentially collecting, storing, labeling data, and then perhaps applying machine learning algorithm to do A/B testing, and this is on a very high level. Now, to do that, you can perhaps take you can start with a small workshop on data science, and again, these workshops are pretty much available on meritroad.com. And if you like the web workshop, if you see yourself getting connected to data science, to the very theme of data science, because it needs a lot of analysis. You need to have a very focused kind of an approach, right? So if you feel some kind of a connect with data science, then you can enroll for long-term courses which span for 3 to 6 months. And after doing that, there's a very high possibility of a person of building his career as a data scientist. So that essentially answers the first question. The second question was, did you know data science really help us in fighting COVID so far? And if yes, how? So in last 40 minutes, we have seen that data science did help us in finding out, what are the potential areas which should be put under lockdown, what are the other areas where lockdown should be lifted, right? uh, what are the places which should be where borders should be closed. So we have already seen enough of that, where data science has been applied, and we have really been far better rather than not having data science at all. I understand that people may have a different opinion given the numbers, because they are soaring every day, they are growing every day, uh, whether it's India or outside. But we need to understand that this is an unprecedented situation, right? We did not have enough data sets. What we have today, we did not have it earlier, right? We did not have those data models. We did not have those models earlier, right? So it took the administration some time to come up with a proper solution, and hence we see that yes, we have been able to get a little bit of success as far as applying data science on current crisis concern. Now, the point was that how it helped us, or how is it going to help us in fighting future pandemic? As Mr. Joy mentioned that, it's going to help us in recovery of patients, if you're applying a vaccine to a patient, what is his recovery path vis-a-vis a person to whom that vaccine is not being applied, and many other use cases as Mr. Joy mentioned. So data science is going to be very helpful in fighting future pandemics. As Mr. Joy said, that in every 10 or 20 years, the world goes through such a situation. And I think in any such situation in the future, hope it doesn't happen. But in any future situation like this, the world as a whole is going to be better prepared than what we were today. Because as we see today, as and Mr. Joy mentioned that the data sets of COVID patients are present, in the public domain on the web, and of course that data is unique, ambiguous. It doesn't infringe upon the right of privacy of anybody. So that is again, in a way, such pandemics are bringing all the countries of the world closer. So that's a very good sign, right? And yes, with all that, I would like to conclude today's webinar by saying that thank you very much once again, Mr. Joy Bose, for giving your valuable time to us. And thank you very much to my audience. And please stay tuned for our next webinar, which will be announced very soon. Thank you very much once again.